guys at home, can I get a thumbs up that you hear me and see the board okay? All right, here we go. We are graphing polynomials still. However, today I am going to show you a little detail that is new. I keep talking about these x-intercepts that have multiplicity, so it crosses over or whatnot. Today I'm finally going to show you these x-intercepts that have a different multiplicity, and it causes a change at that x-intercept on the graph. So I have to give you the rules about the multiplicity first, and I know it's probably going to sound like a lot. You'll see when you get to the graph, though, it's probably not that bad. All right, so I've given you your end behavior rules again. So remember, the end behavior depends on the degree and the sign of the leading coefficient, right? Now we have to talk about these x-intercepts and their multiplicity and what effect it has on the graph. So we're going to write our rules down first, and then I'll show you an example, okay? Okay. So first of all, when I say the word multiplicity, what the heck am I talking about? Well, the multiplicity of the x-intercept, right, at the spot where it crosses the x-axis, the multiplicity of an x-intercept, or zero, whatever you want to call it, is the number of times the x-intercept repeats. So let's say you were setting your equation equal to 0 and solving. Let's say you got the answer x equals 3, right? Well, that means we have a multiplicity of 2 because the x-intercept repeated 2 times. I mean, clearly, there's not like 2 number 3s on your x-axis to put 2 dots at. No, you put 1 dot at x equals 3, but you got that answer twice. So it has a multiplicity. And since it had a multiplicity of 2, we call that an even multiplicity. And it makes a specific change at that spot. So what kind of change it makes, though, depends on whether it was even multiplicity, it repeated an even number of times, or whether it has odd multiplicity and it repeated an odd number of times. So now we're going to start talking about that even and odd again. So you're going to have even and odd degree functions, but now you're also going to have even or odd multiplicities. So try to keep it straight. It definitely can get a little confusing. All right, so here are the rules. The multiplicity of an x-intercept, or 0, determines whether the graph of the function will actually still cross the x-axis, or will it just touch the x-axis, but not cross over. All right, so I say it will just touch, but I call these ones a bounce. All right, so maybe it'll just touch the x-axis or bounce on the x-axis. And that'll make more sense when I'm actually showing you on the graph. Okay, well, which one's which? Which multiplicity will make the graph still cross over at that x-intercept? And which multiplicity will make the graph just touch the x-axis or just bounce off the x-axis? Well, guys, if the x-intercept, or 0, has odd multiplicity, which means you only got it 1 time, or you got it 3 times, or it repeated 5 times, that would be odd multiplicity. Those are the ones where the graph is still going to cross over the x-axis. So if it has odd multiplicity, the graph will cross over. So technically, those ones should feel no different. If it's got odd multiplicity, if it repeats an odd number of times, you're still crossing over the x-axis at that x-intercept. However, let me put a little bit of a side note. When the multiplicity gets higher, like let's say it repeated 3 times, or it repeated 5 times, maybe it repeated 7 times, all right? The higher the odd multiplicity gets, it does have this flattening out effect on the graph at that x-intercept, but guys, it still crosses. So you really don't even have to show that to get the graph correct. But I am going to put a note. The higher the multiplicity, the graph gets a little flat at that x-intercept. The higher the multiplicity, I'm going to abbreviate that, it kind of flattens out. But the good news is it will always cross over. So you don't even have to make it flatten out, and your graph is still going to be correct. Okay, well, that means the sign of f of x, which is your y coordinate, the sign of your y coordinate will change from one side of the x-intercept to the other. And I'll explain that on the graph. So that means the y-coordinate will be positive on one side of the x-intercept, but it'll be negative on the other side of the x-intercept because you've crossed over the x-axis. You've crossed over where it has a change in positive and negative y values. All right, well then what about the x-intercepts that have even multiplicities? These are the x-intercepts where the graph will not cross over the x-axis anymore. All right. And again, I'm sure this is confusing because rules are always confusing as you're writing them, but when you see how we use them, I'm telling you, it'll become a little bit like second nature. You'll get it. All right, so this means at an even multiplicity x-intercept, the graph will not cross over the x-axis. It'll just touch the x-axis. I call these ones a bounce. It's going to look like it bounces off the x-intercept and goes back in that same direction. It doesn't cross over. So it just touches the x-axis or it bounces off the x-axis. Okay? So since it's not actually going to cross over the x-axis at this x-intercept, it means the sign of f of x, the sign of your y-coordinate, will not change. It'll stay the same sign on both sides of the x-intercept. Okay? All right, so let's see how we put this to good use, all right? So just remember, if it repeats an odd number of times, cross over, like normal. If it repeats an even number of times, then we don't want to cross over. We have to bounce at that x-intercept, all right? All right, so guys, look at example 1. I want to show you some tips and tricks, though, just to kind of help you make sure that we're still getting the correct degree of our polynomial function so we can get the end behavior correct. Look at the first one. If I want to sketch the graph of this polynomial function, it's still in factored form, thank God. You don't have to factor. Let's set this equal to 0, and let's start getting our x-intercepts. But if I could give you this tip, guys, look at your factors. I have one factor of x plus 1. I have one factor of x plus 3. This is an x minus 4 factor, but it's squared. Guys, that means there are 2 of those factors. So I like to rewrite it so I can see all of them. So I have 1x plus 1. I have 1x plus 3, and I'm going to have 2 of them because it's squared. So x minus 4, and then x minus 4. I like to expand it. I like to write them all out so I can see, oh, I'm going to get the same answer twice there. And it helps when you multiply your fronts that you get the right leading term. So I highly recommend rewriting. All right, here we go. Let's set our factors equal to 0. I'm going to get x equals negative 1. One time, that's normal. We're going to cross right over at that x-intercept. I'm going to get x equals negative 3. One time, that's normal. I'm going to cross right over at that x-intercept. But guys, then I'm going to set this factor equal to 0. I get 4. I'm going to set this factor equal to 0, and I get 4 again. So that is a x-intercept that repeated 2 times. So we would say this one, and I circle it to kind of remind myself that he's special. He has multiplicity 2. That's an even multiplicity. And what did we say the graph is going to do at an even multiplicity? That's a touch. That's a bounce. So I even leave myself a little note. That's going to be a bounce. Just to remind myself, he's not a normal x-intercept. He is special. All right, let's plot him on our graph. Try to leave yourself some space so we're not doing any tight turns. We got what? Negative 1. And he's normal. Great. We got negative 3. He's normal. But then we had 4. He was special. He had an even multiplicity, which means it's a bounce. So sometimes I'll even put like a little ring around it to remind myself, he's not normal. Something special is going to happen. Because it's easy to forget that you have these special x-intercepts and you just start filling the graph in like normal. So I try to mark it to remind myself, I got something special there. All right, let's get the y-intercept. The y-intercept is the only other official point they make you put on the graph, right? So x has to be 0, so I got to plug 0 in. Well, if I plug 0 in, I'm going to plug it into the one that I expanded. I'm going to get 1. I'm going to get 3. I'm going to get negative 4. And I'm going to get negative 4. All right, well, guys, negative 4 times negative 4 is 16. 16 times 3 is 48. 48 times 1 is 48. It's a positive 48. So now I know my y-intercept is all the way up here. And again, all we really care about is that the y-intercept is above the x-axis. It's a positive number. All right, now we got to get that end behavior, right? So we can figure out who's up, who's down. In order to do that, I need that leading term. So let's multiply our fronts together to get that leading term. That's another reason why I like to expand this. If you multiply these fronts together, you might be like, oh, x, that's x to the third. But really, this one's an x squared. So I really think expanding it, make sure you get your leading term correct too. So I'm going to get x times x times x times x. Guys, that's 1, 2, 3, 4 x's. That's x to the fourth with a positive leading coefficient. So that's a 1x to the fourth. That means this is a degree 4 polynomial. And what do we know about degree 4 polynomials? That's even. The end behavior has to be the same, both up, both down. The leading coefficient is positive 1. So guys, if the leading coefficient is positive, which one is it? Both up, both down? Both up. So to the left of your last x-intercept, guys, we got to end up above the x-axis. So give yourself a target. To the right of your last x-intercept, we got to end up above the x-axis. So give yourself a target. All right, so guys, maybe watch this. So watch me fill this in. So what's going to happen is I like to start left and work my way right. So I'm going to start up here, and I'm going to head towards my first x-intercept. Guys, -3, he was a normal x-intercept. Cross right over. All right, then I'm going down. But my next dot is up here. So somewhere in between there, my graph has to turn, make it turn. All right, now we're coming back up. This x-intercept, guys, was -1. He was normal. Cross right over. All right, now my graph has to get to that y-intercept. So I'm going to go up and hit it. Guys, maybe it turns there. Maybe it keeps on going. It doesn't matter. We're still above the x-axis. That's all that matters. All right, but my next dot is over there. So I am going to have to make it turn, so start making it turn. All right, now this is the new one, guys. This x-intercept is not normal. He had a multiplicity of 2. He repeated twice. So that means the graph will not cross over the x-axis when we get there. It's literally going to hit it and bounce right off of it and keep going in that positive direction. So it's going to go, it's going to bounce right off of it and go right back up and stay above the x-axis. It does not cross over to the other side. And then that is what your graph should look like. I'm out of x-intercepts and my graph should have ended up, so stay up. So now you're going to have these x-intercepts where the graph will not cross over. It bounces and stays on that side of the x-axis. So this is what I mean. On this side of the x-intercept, the y-coordinate was positive. On this side of the x-intercept, the y-coordinate is still positive. It doesn't change on either side of the x-intercept because you never crossed over the x-axis. See, on this left side of the x-intercept, the y-coordinate is positive. On this side of the x-intercept, the y-coordinate is negative because we crossed over. There's a change in that y-coordinate when you cross over the x-axis. All right, how do you guys feel about that? You guys okay? Awesome. So again, that's the new thing. We got to bounce now on these even multiplicities. All right, let's try it again. Let's just keep practicing. And the more we practice, the better we will get. Oh, that's too high. All right, let's do number 2. Right, we're going to sketch this graph. It's in factored form, thank God. Let's set it equal to 0. Let's start getting our x-intercepts. So guys, if I take this factor, the 4x to the third in front, it's all attached. So think of it as one factor. If I take 4x to the third and set it equal to 0, right? Let's get x to the third by itself. So divide 4. X to the third equals 0. But remember, how do you make an x to the third? An x to the third is an x times an x times an x 3 times, right? So now that I've expanded it, now when I set this factor of x equal to 0, I get 0. When I set this factor of x equal to 0, I get another 0. When I set this factor of x equal to 0, I get another 0. So really, when you set x to the third equal to 0, yes, you get 0 as your x-intercept, but guys, you get it 3 times. So this repeats 3 times, which is an odd multiplicity. So the good news is, guys, it's going to cross. So you can treat this like a normal x-intercept, and I can't mark you wrong. The only technical detail is that as the multiplicity gets higher, there is going to be this little bit of a flattening out effect that happens at this x-intercept, because at the end of the day, it crosses, and that's all that matters. And that's all you guys have to show, is that it crosses. All right, let's go to this one. If I set this factor equal to 0 and solve, it's a quadratic factor, so I should get 2 answers from it. Add the 9, square root both sides, x equals the positive and the negative version of the square root of 9, which is 3. So I get positive 3 and I get negative 3, which, guys, those are 2 completely different numbers, so nothing repeated. All right, let's plot. Try to space it out. All right, we got 0, but guys, remember, technically 0 was special because he repeated 3 times. So I'm going to mark them just to remind myself, but at the end of the day, guys, if it's odd multiplicity, you guys can treat that like normal because it's still going to be a cross. All right, and then we're going to have negative 3 and positive 3. All right, guys, what do you automatically know your y-intercept is the minute your x-intercept is 0? It's already crossing the y-axis where? At 0. So you already know your y-intercept is 0. I'm going to write it down just to make sure you know that it's part of the motions. It's still something they're going to ask you to find. But you should know the minute you have an x-coordinate, an x-intercept at 0, when you plug 0 into this function, that means 0 is coming out. Your y-intercept is definitely 0. All right, now let's get our leading term so we can figure out our degree and our leading coefficient. So let's multiply our fronts. Well, guys, your fronts are 4x to the third times x squared. That's 4x to the fifth. So that means this is a degree 5 polynomial, which means it's odd. And what do we know the end behavior on an odd degree graph has to be? Different. One up, one down. Who's up, who's down? We need the sign of the leading coefficient. The leading coefficient here is positive 4. So if the leading coefficient is positive, is it up on the right, the positive side of the graph, or is it up on the left, the negative side of the graph? Up on the right. So to the right of your last x-intercept, you have to end up above the x-axis. To the left of your last x-intercept, you got to be different. Now you got to be down below the x-axis. So give yourself a mark, give yourself a target. All right, now guys, watch this one. Watch this. So let me fill this in. I'm going to start down here. I'm going to head towards my first x-intercept. Guys, negative 3, he only happened once. That's a normal x-intercept. Cross right over. So now the graph is going up, right? My next dot is down here, so I have to turn. So make it turn. I know this is it. If I'm you guys, right? If I'm you, 0 repeated 3 times. That's a odd multiplicity, so it's still gonna cross. If I'm you guys, I'm just crossing right over. Just cross right over. Just make it cross. Technically, though, this is what happens. Because it repeated 3 times, that odd multiplicity, the higher the repeats get, as you approach that x-intercept, the graph actually, it starts to like flatten out a little bit as it crosses over and then goes back down. So I used to call this a sit. I used to feel like it looks like it's making a chair and the graph is just sitting, pausing for a second, and then continuing on. You don't have to put the flattening out if it's going to be too much for you to deal with. I get it. The important part is, guys, it still crosses. It's still crossing over the x-axis, and that's all you really have to show. But it does have this little bit of a flattening out effect. And then, guys, if it repeated 5 times, it would flatten out even more as it crossed over. It just has this kind of slowing effect as it approaches the x-intercept. But you really don't have to show that. Just make sure it crosses. All right, so now my graph is going down, but my next dot is over here. So now I got to go back up. That was a normal x-intercept, so cross right over. And then I don't have any more x-intercepts, and I'm up, so leave it up. And there's your graph. So again, you really don't have to show the flattening out. Just make it cross, and you'll be fine. All right? How does that one feel? Everybody okay? So you've seen an odd multiplicity now, which is really just cross, and you've seen an even multiplicity, which causes that bounce. Guys at home, can I get a thumbs up that you guys are okay with these new x-intercepts? All right, let's keep going. Let's keep practicing. Look at the next example. Oh, I think I can leave it there. All right, if I'm going to sketch this one, right, it's in factored form, thank God, but I'm going to tweak it. If I set this equal to 0, Guys, I got all these exponents, right? So really, this means I have 3 factors of x plus 4. I like to expand it. I like to write them all out. It's going to help me get my leading term in the end. So I know it takes an extra 10 seconds, but I think it's worth it. So let's rewrite this. I have 1 negative x. I have 3 of these. So x plus 4, x plus 4, x plus 4. All right, I got 2 of these factors because it's squared. So x minus 3, x minus 3. All right, now let's set our factors equal to 0 and solve. Guys, if I set negative x equal to 0, divide by negative 1, you're getting 0. You're definitely getting 0 as an x-intercept, and you're only getting it 1 time. All right, so that's x equals 0. He's normal. Guys, the minute you have an x-intercept at 0, what's our y-intercept going to be? We already know the y-intercept. It's also 0. All right, then I'm going to set this factor equal to 0. I get negative 4. I get negative 4 again, and I get negative 4 again. So guys, that's an x-intercept that repeated 3 times. So that's odd multiplicity. So at the end of the day, guys, he's really normal. We're going to cross over. I'm just going to remind you, though, it does have a little bit of a flattening out effect now that it has repeated 3 times. But all you have to do is make it cross. All right, and then I'm going to get x equals 3 and x equals 3. He repeated 2 times. That's a big deal. That means he has even multiplicity, and the graph will only bounce at this x-intercept. It'll just touch it, but not cross over. So I'm going to make a note. That's a bounce. That ain't no cross. All right, let's plot. I got 1 at 0, and he's normal. I got 1 at negative 4, and technically he's not normal, but you guys could treat it normal. You just got to cross. It's odd multiplicity. Just cross. All right, and then 3 is the big one. He's the one that repeated twice, so he's the one that really acts differently. So I'm definitely going to mark him. All right, we already said our y-intercept is going to be 0 because our x-coordinate was 0. But I still like to make note of that because delta math, tomorrow when we finally get to do delta math, they're going to ask for y-intercepts. All right, now we need that leading term, which again is why I like to expand it. It helps you get that leading term. So let's multiply our fronts. Negative x times x times x times x times x times x. Guys, that's 1, 2, 3, 4, 5, 6 x's. That's x to the 6th with a negative leading coefficient. That's a negative x to the 6th. All right, so that means the degree of this polynomial is 6, which is even. And what's the end behavior of an even degree graph? Both up, both down. If the leading coefficient is negative 1, like it is here, which one is it? Both up or both down? Both down. So now to the left, we got to end down. Below the x-axis, give yourself a target. And to the right of my last x-intercept, I have to end down. Give yourself a target. All right, let's see how this one fills itself in. So I'm going to start down here and head towards my fourth one. Now remember, the negative 4, guys, he was the triple, right? He was the one that repeated 3 times. So in reality, all you got to do is cross. It does, as it approaches, have this little bit of a flattening out effect as it crosses over, but guys, it crosses. So just make it cross. All right, so now we're going up. Now I have to go to the next one, so I got to turn. Remember, 0 was the good guy. He was normal. 1 time, cross right over. All right, so now I'm going down, but my next dot is there, so I'm going to have to turn, so make it turn. And guys, this is the important one. That is the x-intercept that repeated twice. It had even multiplicity. So we're not going to cross over. We're going to bounce and then stay below the x-axis. We don't go to the other side. So we're going to hit it and bounce and stay down. We don't actually cross over. All right, and then I had no more x-intercepts, and I had to stay down, so leave it down. And that's what your graph should end up looking like. Okay? So again, we now know this is where the y's are negative, positive, negative, and then they stay negative on the other side of the x-intercept as well. All right, how do you guys feel? You guys okay? Yes, at home, thumbs up? All right, we have one more, I believe. I don't know if I'm going to be able to get it in. Let me just talk about it to get you started, and then you can check my notes that I put on Google Classroom. What are we here till 33? Think so? I have like 3 minutes. Let's see if I can at least get you started.
Probably 2 because the bells are early.
Oh yeah, the bells are early. All right, so guys, really quick. I know I'm trying to rush this. Let's set it equal to 0, and then let's expand it. I'm going to leave negative x squared as negative x squared. I'm going to expand him when I set that factor equal to 0. So then I have one factor of x plus 2, and then I have 2 factors of x minus 5. Okay, let's set our factors equal to 0 and solve. Guys, if I set negative x squared equal to 0, I'm going to divide the negative 1 away. I get x squared equals 0. But really, how do you make an x squared? That's an x times an x, right? So when I set this factor of x equal to 0, I get 0. When I set this factor of x equal to 0, I get another 0. So you have an x-intercept at 0, but guys, it repeated twice. That's an even multiplicity. That's a bounce. It will bounce at x equals 0. It also means, guys, if you have an x-intercept at 0, what's your y-intercept? 0. Okay. All right, then I'm going to get x equals negative 2. He's normal. And then I'm going to get x equals 5 and 5 again. So, guys, that's another even multiplicity. That's another bounce. Okay? All right, so if I plot them, 0, 5, and negative 2. I'm going to fill this one in just because the bell's going to cut me off. Guys, negative x squared times x times x times x, that's 1, 2, 3, 4, 5, a negative x to the 5th. That's going to be up on the left and down on the right. So watch this one. I'm going to hit negative 2 like normal because he was normal. I'm going to turn. 0 was a double, so I bounce. I got to turn. 5 was a double, so I bounce again. 2 bounces on that one. All right, guys, there's no homework tonight. I did not assign a new homework. Let this double, roots, whatever, even multiplicity sit and simmer. All you have to do is finish yesterday's Google Slides. And yesterday's Google Slides don't have this yet. You do not have any homework problems that have the bounces or anything on them, all right? All right, at home, I'm sorry this is rushed. Guys, are you okay here? Okay, I'm going to double check your attendance, and then I'll let you guys get out of here.